Hello everyone and welcome to TLE Eliminators CP-31 Sheet Solutions. Today we'll be discussing the 1600 rated problem, erase and extend. So let's pull up the CP-31 sheet and let's open up the problem. Okay, erase and extend easy version. You have a string S and you can perform two types of operations on it. Delete the last character of the string or duplicate the string. Alright, so duplicate the string means S equals S plus S. So you can do this operation any number of times. Your task is to find the lexicographically smallest string of length exactly k, which can be obtained by doing these operations on the string S. So basically we need to find the smallest lexicographically smallest string, such that when we do these two operations, which is delete the last character or duplicate the string, we get the smallest possible string. Alright, so n and k both go up to 5000. So quickly we can just write up the expected time complexity. So as you can see, the expected time complexity here would be maybe big O of n squared or big O of n times k or something like that, right? Since n and k go up to 5000. All right, so how do we approach this problem? Let's try to figure out obviously what their operations mean, right? What are these operations and what do they signify? So let's say we're given a string like string is like EABC. Correct. So what are the two operations which we have? One of the operations is delete the last character, right? Delete the last character. And the other operation is that duplicate the current character, duplicate the current string, right? So let's say we did two deletion operations, then our new S would be equal to, let's say, DA, right? Two deletions, and then let's say we did two duplications, right? We did two duplications. Then what would we get? We would get an output of S equals DA, DA, right? And then DA, DA, right? So this would happen if we did two duplications after two deletions, right? So how do we approach this problem? Obviously you can try to think of many ways, like you could try to get some greedy ways, some hashing type of ways to solve this problem. But to solve this problem in the expected time constraints, it is actually pretty simple, and it only rests on one observation, right? And the following observation is crucial. So the observation is this, right? That given your input string, right? Given your input string, let's say your input string was A, B, C, D, E, F, correct? Then the possible strings which you can create from this, are either the doubling of A, B, C, D, E, F, right? So what do I mean by doubling of A, B, C, D, E, F? That means that you don't do any deletions. You just keep repeatedly doubling A, B, C, D, E, F, and we get this pattern of A, B, C, D, E, F, A, B, C, D, E, F, and so on, right? And then we can take the first k length characters from this, right? So this is what we call just doubling A, B, C, D, E, F, doubling the whole string, right? Doubling the whole string, and we take the first k characters because we chopped off the rest of them, right? So doubling the whole string, this is one possible answer which we can get. Or what we can do is, this is our input string, right? So let's say this will mark as this is our input string, okay? Or we can chop off the last character and then we can double it, right? So we're given an input string A, B, C, D, E, F, then we can chop off, let's say, F, right? And then we can start doubling, and what will we get? We'll get A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, C, D, E, so on, right? And then we can again, once we are doing this doubling, we can take like the first k characters from this string, right? Similarly, we could have another case which would be something like we chopped off the first two characters, right? A, B, C, D, E, F, and then let's say we chopped off E and F, right? So like this we chopped off. Then what would we do? Then we can do basically A, B, C, D doubling, right? This remaining A, B, C, D would double, right? And all possible strings will fall into one of these categories, right? This is because we cannot add any extra characters. We cannot add any extra characters, right? Any extra characters. The only way to add a new character is by doubling, right? Like the only way the string length is increasing is by doubling. String length increases only by doubling, right? So all the possible strings can be formed by either deleting one character, deleting two characters, three characters, so on, and then like for example, so on, we can go all the way till having only one character left, right? We deleted everything. Let's say A, B, C, D, E, F, and we deleted everything except A, right? And then when we repeatedly double A, we get a string like A, and so on after doubling A. And then in this also we can take the first K character string, right? So basically what we have observed is that we can delete some characters in the start and then double that string and take the first K characters from it. And no other strings are possible because the only way to increase string length is by doubling. And initially, basically, we can only cut characters out and then start doubling, right? So basically, this is all possible strings. Okay? Strings we could get, right? We can get, right? So basically, if these are all the possible patterns which we have, total how many patterns are we getting? It depends on how many we have cut from the start, right? So basically, we deleted 0 from start, then started doubling, right? Then doubled and took the first K characters, then doubling and took first K characters, right? Right? Or maybe we deleted, let's say, 1 from start and then doubled, right? Then doubled and then took the first K, right? And so on. These are all options. So total we get n of these cases, right? And then to make the string itself, we get K options, right? So the length of the string will be K. So we basically need to compare. We need to compare basically n strings of length K, right? N strings of length K. Now you might ask a question like, why, for example, can we not have a mix of operations? Why not do some doubling, then some deletions, then some doubling again? Okay, and let me tell you why that kind of cases do not need to be considered. So for example, we have let's take something like DCBA, okay, and let's say that the optimal strategy is to double once, right? Then cut off some characters, right? And then double again, right? Then double again. And then we, let's say we get something like this, right? And I'll tell you why this strategy is not, it will never give us like any answer. And the reason is that basically, if we had to cut off these at this point, right? If we had to cut off these at this point, that means that whatever value is coming in here, that has to be lexicographically lesser, right? That has to be lexicographically lesser, then only we will cut off at this point, right? But the thing is, if we are cutting off from here, then that means that we should have, ideally we should have just cut off directly in the original string, right? So there is no reason to double then do the cutting off, right? There's no reason to double then do the cutting off, because if we have to do cutting off, then it's better to just do it before doubling itself, right? So then the whole string even here will be smaller, right? So that's why there's no reason to consider like mix of doubling and cutting off. We only need to consider, first we cut off how much ever we can or how much ever is needed, and then we start the doubling process, right? There's no case where we need to first double then cut then double again, right? So that kind of cases will not happen. It's always first cut then double, and we take the first K characters of that, right? So this is the main slash greedy idea, and the idea is that first cut then double, right? There's no like double cut double again, something that won't happen, right? Then take K characters, right? So basically we have to choose between, so from this we have concluded that have to choose between n strings of length K, right? Of length K, and if we just simply generate these strings like directly, it will be big of n times k time complexity, right? And since both n and k go up to only 5000, this is perfectly valid for us, right? N and k only go up to 5000, so we can say that this is a valid solution, right? So nk is less than equal to 5000, so you can say that this is a valid solution. Time complexity of the solution is n times k. Memory complexity, since we're doing the doubling, it can be something like big of n plus k ish, right? And I'll show you the code and you'll see why this is the memory complexity. Okay, let's have a look at the code now. Right. So we take in n and k, we take in the string s, and we have a string called answer of size k, and it is filled with all z's because we're trying to minimize this string. So we're making it the largest string possible. Later it will get minimized. Okay, so we will make a temporary string, and length will be the length of how much we are starting with, right? So either we cut off 0 or cut off 1, cut off 2, so on. So length will be the length of the remaining portion, right? So here the length of the remaining portion is 1, right? And so on. You can have length 2, length 3. Here the length of the remaining portion is 4 when we start doubling, right? So basically we will, for each length, we're going to calculate how much, what string we can get when we double that, right? So we take substring from 0 to length, and while the size of this t is less than k, we will double it. Okay, while the size of the t is less than k, we'll double it. Then we will again take substring from 0 to k to make sure it's size k, and we will check is the answer minimum or this minimum, and we'll update the answer, right? And then finally we can print the minimum string which we got in all these n strings, right? So that's all for this question. Pretty straightforward brute force question with a slight maybe slightly tricky observation, not sure. Like if you're used to greedy ideas, then pretty straightforward. So yeah, brute force / greedy ideas in this question. All right. Although obviously this question is very generic, so it can be solved in many ways. But yeah, this is the easiest way to solve it in the given constraints. All right. Thank you for watching, and see you in the next solution. Do rewatch and do solve the question yourself, right? All right. Bye bye.